Electrical metallic tubing, or EMT, remains permissible for exterior installations on commercial buildings. It's important to understand the stipulations of the National Electrical Code, specifically the 2005 edition in this instance concerning its use in wet locations. The code does not entirely prohibit EMT in such environments, but it does restrict the application of standard compression fittings without additional protective measures. The critical aspect is ensuring a watertight raceway system when EMT is exposed to wet conditions. This necessitates employing methods and materials designed to prevent water ingress into the conduit system. One acceptable method involves the use of conduit bodies. These are specialized fittings designed to provide access to the interior of a conduit run for pulling wires, making splices, or providing additional bends. When used in wet locations with EMT, these conduit bodies must be equipped with watertight seals. These seals are typically gaskets or other sealing mechanisms that create a barrier against moisture entry. The purpose of the watertight seal is to maintain the integrity of the electrical system by preventing water from coming into contact with conductors or other electrical components. This is essential for preventing corrosion, short circuits, and other potential hazards. Therefore, while standard compression fittings alone are not considered adequate for wet locations under the 2005 NEC, EMT can still be used if installed in conjunction with a watertight raceway system. This often involves the inclusion of conduit bodies with appropriate seals. It is important to consult the specific requirements of the applicable electrical code and local amendments to ensure compliance with all regulations. Always refer to the most current edition of the NEC and any local amendments enforced by the authority having jurisdiction or OJ in the specific location of the electrical installation. Electrical codes are updated regularly to reflect new technologies, safety concerns, and best practices in the electrical industry. Understanding the relevant sections of the NEC is crucial for electrical contractors, electricians, and anyone involved in the design, installation, or inspection of electrical systems. In addition to the general requirements for wet locations, the NEC also addresses specific applications and environments where additional precautions may be necessary. For example, in areas subject to corrosive atmospheres such as industrial facilities or coastal environments, additional measures may be required to protect EMT and other metal raceways from corrosion. This may involve the use of special coatings, corrosion-resistant materials, or other protective measures. The NEC also provides guidelines for supporting and securing EMT to ensure that it remains properly installed and protected from physical damage. Proper support is essential to prevent the conduit from sagging, bending, or becoming dislodged, which could compromise the integrity of the electrical system. The NEC specifies the maximum spacing between supports for different sizes and types of EMT, as well as the methods for attaching the conduit to structural elements. These requirements are designed to ensure that the conduit is adequately supported and protected from mechanical stress. Furthermore, it's also crucial to ensure proper grounding and bonding of EMT systems. Grounding and bonding provide a low impedance path for fault currents to return to the source, which helps to protect personnel and equipment from electrical shock hazards. The NEC specifies the methods for grounding and bonding metal raceways, including EMT, to ensure that the system is properly grounded and bonded. This typically involves the use of grounding conductors, bonding jumpers, and other grounding devices. Always refer to the specific requirements of the NEC and any local amendments for detailed guidance on grounding and bonding electrical systems. Additionally, consider the environmental conditions of the installation site. In areas with extreme temperatures, for instance, expansion fittings may be necessary to accommodate the thermal expansion and contraction of the conduit. Without these fittings, the conduit could buckle or crack, potentially compromising the integrity of the electrical system. Similarly, in areas subject to seismic activity, special seismic-rated fittings and supports may be required to ensure that the conduit system remains intact during an earthquake. The NEC provides guidelines for seismic design and installation of electrical systems, including requirements for bracing and anchoring conduit. Always consult with a qualified engineer or electrical professional to ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. Continuing education and training are essential for electrical professionals to stay up to date with the latest changes and advancements in the electrical industry. Many organizations offer training courses, workshops, and seminars on a variety of electrical topics, including the NEC, electrical safety, and new technologies. Participating in these educational opportunities can help electrical professionals enhance their knowledge and skills, improve their job performance, and advance their careers. In summary, while the 2005 NEC restricts the use of standard compression fittings on EMT in wet locations, it does not prohibit the use of EMT in such environments altogether. By employing appropriate methods, such as using conduit bodies with watertight seals and adhering to all applicable code requirements, EMT can still be used safely and effectively in wet locations on commercial buildings. Remember to always consult the latest edition of the NEC and any local amendments to ensure compliance with all regulations. Consider also the specific environmental conditions of the installation site and take any necessary precautions to protect the conduit system from damage.